Morning, everyone. I want to talk about what we call the dynamic media factory today. What is that actually? It's an initiative, a program we have started with most of our customers to turn them into a more agile, more software-driven and also more data-driven companies. When we look into the situation today, what is the market situation out there? Everybody knows that's nothing new. Media is becoming more IT. On the other hand, what do we see within the broadcasters? They have all the knowledge in media. We know about linear, non-linear streams, files. We have the right toolings to do that. That's often bespoke technology, tailor-made platforms. Pretty complex at the end of what we have built over many, many years to glue everything together. And at the same time, we try to become more an ICT company in a media facility. And there we have other concepts. Everything is much more data-driven. People talk a lot about DevOps, CI/CD platforms, continuous integration, continuous development and deployment as well. Turning companies into more agile organizations, that's something you see when you want to embrace IT and ICT concepts. Working community-based, having change management programs in place, that's not something we are used to do in broadcast or with our customers. And security, maybe one of the most important topics there. But why are we not just going and use those standard IT tools or ICT tools? Because media has its own specifics. That starts with high bitrate flows, different expectations when we talk about real-time or high availability. And we somehow need to meet in between, make use of some of those ICT concepts, but at the same time, our industry has its own specifics out there. Another thing everybody is aware of, media is becoming way more complex than it ever was before. The good news is we have all that, what we call transformation and technology at hand. We can go 2110, we can go IP now, we can go to the cloud, we have things available in software, we talked best of breed, 5G is there, we can use LEO satellite constellations, everything is available at hand, but how to use it, you cannot just pick and choose the technology for the sake of using new technology. You need to build what we say a composable architecture that really allows you to do what you need to do as a media company, scheduling resources, controlling, automation, talking about orchestration as well, but at the same time, use the IT concepts out there, which is managing code, repositories, having a CI/CD pipeline in place. That needs an architecture in a company. What companies need to look into first to make use of those transformational technologies. And when we talk to companies, the first thing we do is, why are we using technology? What do we want to achieve? And that's really towards company goals. It's not a goal to replace SDI with IP. There is no benefit for any company out there. It needs to follow more the company goals. That's certainly improving efficiency. Just a couple of examples. Resource optimization, you want resources only when you need them. Improving security, reducing carbon footprint, also empowering remote workers. We have heard about something about from Andy today, working remote, but also looking into new workflows. And everything needs to go around those company goals. Make use of the technology, have that architecture in place that allows you to use technology, and then we call it a dynamic media factory. What's also important, that composable architecture, that's not a product you can buy out of the box and might never be any product you can buy from anybody out there. We talk here about what we say easy to use and modular solutions. How do we get there? Easier said than done. This is something we don't do with customers in half a year or in a year. This is typically a multi-year project or initiative. And first thing we do, we look into workflows. Everything we do, or when you go into those digital transformation projects, we say you need to digitize workflows. And when you look into a workflow in media, they're all pretty similar, no matter if you do something in an MCR, a downlink, a 4G contribution, or if you do playout, everything has a life cycle. That sense of time, Andy, you mentioned that, that's important to look into that. And things start with Creating inventory. There we have NMOS to find your physical inventory, the assets, but also the network topology. Creating bookable resources, that's an important thing when you want to make use of your resources, of your inventory you have at hand. But also think of IP address management tools. A lot of IP addresses are managed on Excel sheets today. That's not what we call a digitized workflow when you have an Excel sheet and need to do copy-paste from those. Also creating virtual signal groups when we talk 2110, that's not something which is there out of the box. This is administrative data. That all goes to the inventory. Then planning, everything you do. Oh, that was a bit, somehow goes along with planning. I see a different thing here than here. Sorry, I just realized this is not the same. You plan your work orders, events, productions, also maintenance slots. Planning goes along not only for the media people, but also for IT people. Then resources, think about the infrastructure, your physical resources, but also what we call offline resources, people, rooms, desks, trucks, everything you might ever want to use. Then we heard it before, deploying resources, a concept that didn't exist before. Resources were always there traditionally. Now you plan for something in the future, you have a production tomorrow, and you need some resources, and at the time when you book them, they don't even exist. That's a whole different ball game. But not only cloud resources, what we see a lot is FPGA-based resources that you can reprogram. The one day you have it, you have one IU box which is a multi-viewer, the other day it's a JPEG XS encoder or decoder. And to make use of those resources, to optimize those resources, you only deploy them at the time when you need them. Configuration, this is more what we are used to do since many, many years. You configure devices, but also network. Think about security configurations, host and flow policies in a network, netting to go from one network to another. The control plane then, and connection plane. That's important that we still need to support SDI, legacy systems and formats, and also all the IP world from SRT to uncompressed, etc. This is more what we are used to have since many, many years. Then monitoring, don't forget about that. We say monitoring always goes together with control that cannot be managed as a separate project. And that's monitoring infrastructure, but also monitoring your microservices, your virtual machines, all the stack. Monitoring performance over time when we go into SLA monitoring and monitoring service-centric. You're not interested in an overall health state of everything. Typically, you are interested in the health state of a certain production of something you do, of that certain workflow. And then finishing up things, very important, not to pay AWS EC2 instances forever. You need to turn things down again after you have used it. And at the very end, when you look into a media or any workflow, things have costs. Resources have costs. We need to be able to also track those resources over time and allow handing over then the resource utilization, or for how long did you use those resources, to another team, the billing team typically. And those workflows, that's the interesting or the challenging part. We have those into what we call a multi-environment. You always work with separate teams, different teams. Onboarding is often the IT team. Then you have the planning team, you hand over to the MCR team, playout team, etc. That needs to be managed in one way or the other throughout that life cycle. We have different states in those workflows. It's again that sense of time. It's not a single start or stop and nothing happens in between. You might have a state, what I called here, the infrastructure is ready. Somebody had to approve then my production or my downlink. Then it's confirmed, means I have all the resources associated. I know I have enough resources to run my production. Then it's ready, it's running, it's at the end a state where everything has been done and finished. And then you have processes attached to those states. What do you need to do in that whole life cycle? I need to provision my infrastructure, I need to allocate resources, I need to deploy and connect, etc., etc. And those processes are sometimes manually managed. An approval workflow means somebody needs to hit a button, but a lot of those processes can also be automated. And the only way we think that can be done, we call this a single source of truth. The data we generate here in such workflow, this is data which is not 100% available at the time when you start the workflow. When you start planning, you have some data available, a start time, a stop time, but maybe not the resources and the details and the parameters you need. And over time, when you hand over from one team to another or from one state to another, you gradually add more and more data in the workflow, and you need to make sure that everybody has access to the data he needs. That's important. And to build something like that, yeah, you cannot have PDFs and Excel sheets and emails all scattered across your company. It needs to be that single source of truth, a single database. Technically, that's not probably a single database only, but one database or multiple databases where you glue everything together and store and manage your data over time. Another important consideration when we say all data goes into a single database, we have a lot of data. How to use the data, there is that need for, we say, easy to use and tailored interfaces. A simple example, an IT person looking into a network has a different need compared to a media person who's probably interested in my 2110 flows. The IT person is more interested in the overall network utilization. So they need those personalized interfaces to see the data at the right time, the data they need for a certain job they have to do, and that can be quite dynamic. Sometimes we call it desk-aware. When I take a seat and I have a multi-viewer in front of me, I only want to see the control panel to route to those destinations for that multi-viewer I have in front of me. Task-oriented, that's more production-oriented. When I know I have certain resources booked for a certain production, it makes sense to only show those inputs and outputs on a control panel as an example that I need for that production. And schedule aware, that's again that sense of time that I see data and make data available only for the time when people shall use it. Those interfaces, they come and go. That also has a lot to do with security, by the way, that we don't want to give people controls at times when they shouldn't use things, because it's all one big system. And then again, it's not about reinventing the wheel and starting from scratch. When there are existing interfaces from vendors out there, yet just reuse them when they do the job. There's no need to replace all of them. But more and more we go into those dynamic interfaces. Then how to make that all happen when we say we want to digitize workflows? You need automation, what we call orchestration. I'm always very keen on explaining the difference between what automation is and orchestration is. Automation is running scripts, running certain things at a certain point in time. Doesn't know much, has no sense of time. You just fire something in the future, or right now, you automate it. Scheduling and automation often goes together. You either hit a button now, then you automate probably something, you run that script, or you make it running tomorrow, and this is more a best effort thing. You don't really know when you only use scheduling and automation if things go well tomorrow. It's also more than signal switching. We see a lot of products out there they call like SDN controller an orchestrator, which is valid. We take it a bit broader and say this is more than signal switching and control. What we found, how orchestration is defined when you Google for it, it's often defined as a framework, and I like that very much, to automate the life cycle, again, that sense of time, of services end-to-end, they say, across multiple technology domains. That best of breed is important in orchestration. And most important for us, that includes managing and tracking resources over time and keeping in mind three things. Availability, can I use it, yes or no, or is it booked? Capabilities, is it an SD, HD, UHD capable device? And capacity, that's often when we talk about network capacities. Now how to get there? We call it the composable architecture. Let me explain a little bit what we do and when we say we need to build that composable architecture. You have your end-to-end operations down there, all your equipment, hardware, software, ground, cloud equipment, doesn't matter. And you need to have that data plane accessing the equipment. Data collection and control plane, we call it. There are tons of standards out there, starting with SNMP. We talk a lot about telemetry data nowadays. REST-based APIs, etc. But you need to have some technology that allows to connect with all your equipment, all your infrastructure you have. What we think people need to do, you need to build what we call a digital twin. Get all the data, standardize and unify the data first of all before you make use out of the data. To give one example here, what is standardizing data? When you talk to two different switch manufacturers and you look into, for example, a PTP metric, one manufacturer calls that my PTP mean path delay, the other calls it just delay. You need to unify it for the operators to give them the same name, the same metrics, the same units, etc. Otherwise, they will struggle a bit when you have multiple vendors and they give different names for the same thing. Digital twin also includes administrative data. So here we have data coming from infrastructure. That's for monitoring, for control. But remember, when we want to manage a lifecycle, there's a lot of admin data involved as well. Then on the next level in that architecture is that processing engine, where you manage and digitize and automate workflows, processes, where we talk about automation and orchestration. This is the thing happening in the background. And then we have the data consumption layer with those easy-to-use interfaces, tailored interfaces, but also APIs again, because even if you build something like that composable architecture, you will have other systems that also need data. And those need to be machine-to-machine interfaces, APIs, but that's also a data consumption layer or belongs to data consumption. A brief look into what a digital twin is when we talk about infrastructure data, where we say we have a managed object and to streamline data. A very simple metric here, bitrate. Has a value, but also needs to have units, a min, a max rate, a step size, and to be able to make use out of the data, to make the right decisions with the data, you need to know the history. This is performance data over time, so we store a lot of data. And when data changes or those metrics changes, you also need to have the context. You need to know when I did a firmware update, something changed. You need to know when certain data belongs to a certain service. When my bitrate goes up, because I start a production, that's a good thing. When my bitrate goes up and the production has not been started, something might be wrong. So everything is around having as much as context as possible towards the data you want to use. Also active historical alarms. We talk a lot about also machine learning, AI algorithms to detect anomalies like patterns and also to do forecasting, which is more for proactive monitoring. And altogether, we call that this digital twin. Then administrative data, you need a database. What we did, and there's many solutions out there, standard ICT tools. We are using OpenSearch now a lot. OpenSearch allows us to store all kind of data in a pretty, let's say, unstructured manner. Doesn't really matter what you want to store, you can store it. All the administrative data we will ever need. And those are just screenshots. Probably you can't read too much of one of those data models. And that includes my assets, people, the resources, jobs, events, workflows, signal groups. What's very important for us, as we said before in a life cycle, not all data is available at the beginning when I start a life cycle. You need to have state-aware objects. What is that? You need to be able to define an object and also assign states. And the state could be something like, for infrastructure, it's in draft. And let me see, I guess I have some more screenshots there for resources, for example. You have a state that says, it's in draft, the resource has just been plugged in, but is not ready to be used yet. Then a default one is complete, I can use it. Or there's a deprecated state, for some reason I cannot use it, or you delete it again. That's also a life cycle within itself, just for a piece of infrastructure. And then, like in every other database, you define all the optional, the mandatory fields to make and manage resources, because this is data, this is administrative data that does not come from any infrastructure. You cannot pull a server and get data out that you want to store here. What's also important when we talk about infrastructure, just a small side note here, we interface with all your infrastructure. We said you might have a 4-channel video server. To make it bookable, what you need to do, you need to split it into what we call small manageable resources. Because when you want to book a video server with 4 channels, you don't book the box, you don't book 4 channels, you want to book individual channels. So there is a difference between managing infrastructure and boxes compared to the actual bookable resources. We always say to the customers, you need to define like the smallest chunk of your infrastructure that you can use independently of each other, and that's typically a resource. Otherwise, the resource optimization will be hard when you only are able to book full boxes or devices. And again, resources have availabilities, capabilities, capacities, properties. Properties can be more admin data like a location or some firmware data, cost attached to it, that's also important. We talk about rate cards here. But at the end, it's one big database. Most important for us to make things work is that state awareness, otherwise you struggle to add and remove the data at the right time. Another example here, what we store when we have jobs, a production, a downlink, an uplink, whatever I need to do. Again, we have states. Draft, tentative, confirmed, running, completed, ready for invoice, afterwards cancelled, error, and you can go from one state to another. That's something those databases allow to say, I can go from draft to confirmed directly, but I'm not allowed to go from confirmed to ready for invoice. First, I need to run it. So this is something you can define in those data models to say, how can I transfer from one state to another? That's not necessarily linear. You can always go from running to error or from draft to error, or invoice can only be after a successful run. That's logic you can also store in those data models. Jobs have then again allocated resources, they connect to resources, they need to execute workflows, and have again costs assigned. Like a resource has costs, a job has costs assigned, everything is also about defining those rate cards. What's important on those data models, at the end you glue everything together. This is standard database languages, the way you work. But when we defined it, one of the key considerations was we can only guess what like the most minimal data set is people require in average. And when you look into workflows, how people run, their operations, every customer has a different set of data. So that basic data set we have defined here to get people started needs to be extendable. That's what we did to say this is like the core thing. Let's say people, I define a name, an email, and an address, but some customers, they want to store another 20 things attached to a person. Pretty easy with those databases like OpenSearch that you can just extend it. So next to the databases, we have defined the underlying architecture. Important is again the consumption layer, low-code applications. Those are just examples. Most of them were built by our customers. Why low-code apps? Low-code apps need to be there because people don't have skills or developers at hand to build those apps and go deep into coding. It needs to be simple to build your own app. Build them fast, build them easy. Different teams have different needs. We cannot know. The best person who knows is the operator, and when we give them the tools at hand to build your own app or to tweak the app the way you want, they typically get it, and they also are in, or you get them onboarded to run such digital transformation projects. Because if it's not accepted by the operators or by certain people, those projects will fail. How does it look like for an operator? Just a few screenshots there. It's a graphical interface where you have certain dashboard or app components at hand, and then you can map them with real-time data. Again, important here, the way you build those, it's all embedded in a CI/CD platform. You can evolve during runtime. You can go into an edit mode, you can update and publish, and you can always go back to a previous version in case something went wrong. So that must be built in an architecture that allows you to touch things whenever you want and improve things and evolve. Then one layer back, not everything goes, that was too fast, without coding. When we go more into the core functionality, running automation, orchestration scripts, we talk about IDEs. We have plugins available for Visual Studio. We have then our own CI/CD pipeline. You need a code repository. Typically, you have a catalog. We using GitHub there. There are APIs available that you can run and automate everything really from the first time when you touch and create an automation script up to the point when you deploy it on a staging platform, and then when this was successful, go into production. And that CI/CD pipeline is super important. Otherwise, that's what we have seen. When you don't think about that and when you don't implement this on day one or from day one onwards, you're pretty much stuck. You can deploy a project once and then people are afraid when they want to do a change. A change could be a simple change in an automation script. When you have that automation script running on your production platform, what would you do? You need to test upfront. You cannot just go and do a change. It's way too risky that things might fail. And those CI/CD pipelines, this is all standard ICT toolings. Some examples here, what we are using internally and what we also provide then to our customers. We are using Jenkins, we are using .NET tooling, GitHub, GitLab, Gerrit for code management, .NET tools. It needs to be platform independent. That's something we have learned over time, because our customers, when they want to build their own CI/CD pipeline, they need to reuse some of the scripts, the codings we have done before. And only then, if you go for a platform independent set of tools, that can lead to success. So whatever we do internally, we have everything fully automated. That starts from testing up to the deployment. Very important thing to consider, you need to automate testing as well, not only automating the workflows. And then we need to help our customers, and we see more and more customers adapting to that, to have their own CI/CD platform. That's important. Not only us saying we can do magic things for you, we need to empower the end customers as well. But before we start, there's a couple of things we need to consider, because that's also what we have learned over the last 2 to 3 years. We walked in and said, what do you want to do? What are your workflows? Let's automate everything. Not the best idea. And there are a couple of recommendations out there. This is not done or invented by us. The guy, Elon Musk here, this is his magic algorithm, how he made his Tesla factory and SpaceX work. First thing is like question everything. Do not go in and say, how do you work today? Ask everybody, is it really necessary? And then remove everything you don't absolutely need before you automate. Simplify, optimize, accelerate what he calls the cycle time. This is often removing bureaucracy. And only then automate at the very end. So don't go in and start automating everything you can ever imagine. That's too time consuming, that's too expensive. And what we say, get things right first. That's important before you automate your workflow. So we sit together with customers and say, how do you work today? And when you ask 10 different operators, you end up having 500 different workflows, but then you need to limit the workflows that you want to automate and orchestrate. That's very, very important otherwise, because when you look into it, automating things also takes time, takes resources. That's not for free when you automate. And you can only optimize when you automate a subset, the most important things you need to do first. At the end, as a summary, this is not a technology project. As you know, we provide technology. We have platforms out there. Without technology is also not possible. You need to pick the right technology. Something open, that single source of truth. Pick a good database, which supports those state awareness, stateful objects. It's important. Have something where you can combine administrative data and infrastructure data. Don't split it off. Don't keep your Excel sheets to manage the admin part and then have any other subsystems to manage the infrastructure. And also look into open flexible APIs. That's not new, but very important to remember all the time. And then when we deploy projects now, like almost 50% of the time, of the engineering time we spend together with our customers is embracing them and learning, teaching them how to become agile. There's tons of courses out there in Scrum, in DevOps to build their CI/CD platform. We have everything available at hand for them when they want to do a CI/CD platform. It's all on GitHub. They can use it, and we almost force them to use it instead of us doing the work to really embrace those agile methodologies with the customers. And then at the end, it's about people. We need to empower them, and we need to give them toolings at hand, and something like low-code apps is very important because we are not IT experts. Those people are way too expensive. We need to give them simple tools at hand that allows them to use that new technology and to make something out of it. And also, what we have seen, it's about the collaboration. Collaboration is having the right data at hand, but also still don't underestimate it. A lot of face-to-face events where people can just share their experience. Also in that world, it's important to organize those events where we bring people together to benefit from each other. And that's it. Thanks very much.
All right, thank you. Any questions?